Okay, good afternoon, everybody. It's 1, and we have like a big session today. I hope to cover what I'm intending to do. Today, we are going to learn how to plot curve, how to plot functions. So the first example is really easy. Can you guys hear me well? Everybody hear me? Just to adjust the sound if there is a problem. Okay.
We can hear.
Oh, great. Okay, so I'll continue. I'll go ahead and continue. Well, so the first example is really easy. We have x, the rate of the x, we have like 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 elements in x, 8 elements in y, and I want to sketch y against x. So that's x-axis, y-axis. Important to do any plot, the number of elements in x and y should be equal. Otherwise, we'll not be able to execute the plot command. So as we used to, are going to type clear the memory, clear the screen. I'm going to add another one today. Since I'm going to have a plot, I have to clear any figure. If you didn't do that, you will mess up the old figures that you plot. So now we are adding another one just to save ourselves. CLF, cleared figure. All right. So I'll go back again and show you. That's what we want to plot. So I will enter first the element of x. I remember that. I'm right. I'll say x equal. And I will have 1 space 2 space 3 space 5 space 7 space 7.5 and 8 and 10. And that's the first vector. Oh, I messed up something here. The vector should be closed. The bracket should be closed. Then I will enter y. The elements of y, I have also brackets. Then the value is 2, 6.5, 7, 5.5, 4, 6, 8. So it's like you got data from experiment from the lab, and then you'd like to sketch. So, oh, that should be equal. All right. You got to make sure that the size of x equal the size of y. And last time I showed you the command. If you write size x, it will tell you the number of rows and element. But oh, that's something is not right. X size x 1 by 1. It's 1. Oh, it should be like how many column? 1, 2, 3. Let me print x. See, because that will be a problem. X equal 3. Oh, that's not right. So we have a problem here. Oh, I didn't run the program. Oh, okay. So you got to run the program. Let me now run the program. We did the run. All right. Now. Okay, now I type x. Yeah, that's right. So if I write the size of x, I should get one row and 8 column. That's right. If you write length of x, yes, 8 elements. Also, I want to write length, so I go back. I don't have to type every time. I get the last one and just in x to y, 8. So you are fine. Now we can do the plot. What is the command of plot? Say plot, your x-axis is x, your y-axis is y. That's all. Oh, y. That's all. Let's just run the program. Boom. Then you'll get the figure in different window. Don't be worried. So you go there. That's what you got. So that's x-axis. If you check each point, you'll find just it's exactly the same that where you enter. All right. And of course, sometimes you need to improve the way your plot look like. Like you can add line specifiers and proper property name and things like that. So I will show you what I mean by that. Let me add to this command. Okay, let's just let me add this command plot yx, and I will just say an R. All right, as in this way. So what does it mean R? This R belongs to line specifiers, and I choose the color red. Is it going to do that? You see here, that's it. Tell you when you just type, then it give you the format, and you can type help plot to give you the whole thing. But just I'm taking you step by step. So when you do R, it means that you want to make it in red. Let's see. If we run, you go for Matlab for the window. Okay, it changed to red. All right. Let's do another specifier. What about if you want to make this line to change it to dashed line? All right, connecting points. So what should we do? Well, I will. If you want to keep it red and you want dashed line, that's fine. Just to make this one and 2. All right, that's dashed line and red. All right. So let's see what's happening here if we run this one. All right, here you go. It's red and dashed line. You changed. Well, what else we can do? Well, we can use the point mark with the asterisks. Like, let's say that I wanna use this, choose this, and I want the default. I don't want the red. I want just the default and run and see here. So you got points, asterisks in this way. So you can change, but plot X, Y, and then whatever you want to do. I will give you table. Document has table. Show you how to make it red, blue, black, dashed line, asterisk, dots, whatever you wanna do. Okay. So that's the way that we can control. Of course, there are many things that we can control, but as I promised you, it will be just step by step. Let's now show you another example. We did this one, the first easy one. Now we know the plot. That's the example that we want to do. Just go ahead and look at it. Oops. All right. That's the example. This one. The data here is given. That's the year. And that's the sales in 8 million in 1988, 12 million 1989. So I'm running from 1988 up to 1994. And I want to the plot command to contain the sales data of a company from 1988 to 1944. So let's see how can we do this example. All right. Let's just I will type over this one. I will try to enter the data. So the year, I will call it YR, the year, YR, and it was I would say 1988 up to 1994. If you do, oh, what is that? If you do it like that, Matlab will understand it's a vector, start from 1988 to 1949 with increment equal to 1. But I'd like to write 1, I will tell you why. Because it will give you freedom. If you want to jump every 2 years, so you write 2, you want 3 years, 3, and so on. All right. So now I understand that I will start from 1988 up to 1994 with increment 1. What's the difference between this example and the previous example? The previous example was simple and the data limited, but sometimes you have like 1,000 elements, 100 elements. It's not practical to type them. So it's either you have it in a matrix form or a formula. So I'm going to show you both. Now I'm showing you in matrix form. It's a row vector. All right. And the corresponding data, the sales, that was given. So I write sales. How I write sales? Let me sales, SLE. All right, for example. And the sales at the vector, the first one was 8, 12, 20, 22, 18, 24, 27, and semicolon. Oh, that's not semicolon. Okay. All right. I got to turn on the light in my office. Well, of course, I'm trying just to show you how you enter the data as a row vector. And I'm going to show you, not today, but another session, that if you have an Excel and has like big data, how you enter the Matlab. But the objective today is just to show you how you plot, use plot. There are a lot of things to do. All right. So now I want to make the plot. So let me just take this one. It's not X. My X-axis is the year. So I change it to YR, exactly the same name. And the Y-axis is the sales, which I call it SLE. So now YR, that's the X-axis. The year will be the X-axis. The sales will be Y-axis. That's what we want to do. And let's just say I want to make it like a dash line. And the color is red. All right. We can add more. Okay, let me show you some. Sometimes I use when I was a student that the line thickness is not enough and skinny, and when I copy and paste, it's not clear, and my professor was not happy about it. So I figured out I can control the line width. Just write line width. All right, like that, and then you make comma, and then the thickness, I think 2 is really reasonable. And let's add also marker size. Marker size, I want to make marker size. And marker size will be, okay, I'm sorry, got to have this one, as before, 12. So all these are options. So I'm going to plot X-axis. Year will represent X-axis, the sales will represent Y-axis, dashed line, and the color is red. And the line width you will see is different. 2 will be really good, and the mark size is 12. By the way, you might have an old version of Matlab. If you have old version of Matlab, you start his L will be in uppercase and W in the uppercase, and mark size M will be uppercase and S uppercase. I have this old version, but this I'm using the one here in the university. So hopefully it's a new one. So let's run the program here. All right, when you get clean thing like that, means you don't have error, means accepted. But I just want to tell you, because I dealt with older Matlab, like only 2 years, it will not accept all lowercase like that. All right. So, and you got to check every time you can go write help and write the setting. Let's now look at the window. That's what we got. All right. So that's the Y, that's the, you look at X-axis, can you see it? Can you see the graph, or can you see the graph, guys, or not?
No.
Okay, good, good. All right, all right. Right. So that's the way that the graph is plotted. And the size of the marker is 12. The thickness is equal to 2. All right. But here I don't know why it didn't show the marker size. It didn't show the marker. Oh, you know why? Nobody asked me this question. It's only broken line like last time. A thickness is thick, it's 2. But marker size 12, I didn't see marker. What? I didn't see marker size. Do you know why? Okay. Because here I said it's dashed line, red color, you got to add it here. If you want to add marker size, add the marker size. What the marker size you want? Let me use the star here. All right. Now let me run and I will show you. When you add this after the color, that's corresponding to the marker size. Let's see if I'm correct. Here you go. So you put marker, add the data. So in 1988, that's the value, 8. In 1989, that's 12. 1990 is 20, and so on. So it's very clear now that you can read the data. And whatever between them, you can connect by this line. And the color is red. All right. And I will give you the table, as I said, that shows the color. For example, if you want to make blue, so you write just type B. Okay, maybe B will look better here. Okay, there it's clear. Yes. Great. And you can change the marker size. There are many options. Some people, they like, for example, to have like plus sign or circle. Okay, circle. Yeah, sometimes we would like to have circle or X's. You make it like cross or something. So just see that you put X. I think X will make it like cross. Let's see if it does. Yeah. I will give it a table just to play around. That's nice. You choose the one that you like. But you got the idea. So we are controlling a lot, you know, what we're supposed to do with the blob. Still have more to do that, all right? Okay. Now I want to jump to another example, but please stop me. If you have any questions, just stop me. Okay, we can see the graph. Oh my gosh, you can see the graph. All right, let me share it. All right, we'll share Matlab and the graph. And where is our document here? Yeah, all right. Let me again run the program here. I'm sorry. So I run the program here, and that's what the graph is going to look like. So the width of the line is 2, and the marker size is 12. What's the marker size? The X. I use the cross as the. So since you didn't see the graph, let me show you again. If you change this one to another one, let's have a circle. You just type O. Now I run. I go to check the graph. You got the circles here. It circled the data that you entered here, these values. Okay. So now we can see the graph. Good. Well, that's great. And this is the marker size 12. What's the marker size of the circle? If you want to get it more or less, you can do. All right. You can make it, for example, let's make it 20, just exaggerate and see so you can see the difference. Okay, big, huge. All right. That's the mean marker size. The marker size is different than the line width. Line width is the thickness of this line. Let me just show you. If you make it 4. All right. Oh, thick. All right. So that's under control. Done with this one. Now let's move to a different thing. Let me review what we did. What we did till now. We did the normal plot. Just you have data, very simple data. We got table and want to sketch it. And we just show you how we enter the year, not by typing the year. This is the starting, this is the end, and then increment is equal 1. We did that. Now let's just go. If you want to plot a function, where do you go? We're getting serious business now. So we want to, in this example, we want to plot command, use the function 3.5 negative 0.5x time cosine sec s from x negative 2 up to x4. Please write this down by your pencil. So just write it down. The function 3.5. All right. Cosine 6x from x equal negative 2 to 4. All right. And all right, we'll go ahead and do that. So I will keep the clear CLC, CLF, clear the figure, and just I'm going to change the data here. All right. Let's just have normal plot first, because we want to focus on this function. How you'll do that? All right. Let me just show you here in this example so you know what I'm typing here. The function that I have, the function of x that I want to plot, it's equal to 3.5 to the power of 0.5x time cosine 6x. That's what I want to plot. Of course, I did that in the command line. Matlab will not understand this, but just I type it here not to forget. Well, but I will remind myself the power of -5 times x. That's one. So how I write this function? First of all, I got to enter the data. This one should be plot for x from -2, I think, up to I write equal next to because it means x is greater than or equal to, and x less than or equal to 4. This is the domain, right? And this is the range. All right. So I want to, how you enter x, you should be able to do that. We did that. Say x is a vector. Start from -2 to 4. If you do that, you will get a funny plot, and I'll tell you why. I'm not going to fix it. I want to show you. If you leave it like that, what does it mean? It means the increment is equal 1. It means -2, -1, 0, 1, 2, 3, 4. For like few points. And we have functions changing here dramatically, cosine, exponential. So you need really to have small increment. But I want to show you, because sometimes I remember some students, they did the right programming. When they got the graph, they think they got the wrong one. So let me do that. That's what I'm going to do. When I was student, I started like that. I said, that's what I learned. X from -2 to 4, all right. Y, it will be equal to 3.5 power and -0.5 times x and times cosine 6 times x. And then I will just do plot xy, plot x, y. Well, there is something here. Let me see the equation. 3.5 power -0.5x. I forgot it's not, it's negative. It was negative here, negative sign. 5x times cosine 6x. If you do that, it will be wrong. Do you know why? Let me show you here some example. If somebody know why it's wrong, however, the equation is right. I have the same equation, but it will not do it. Why? Let me just take simple example here. If I say x is equal 1, 2, 3, 4. What does it mean? X has 4 items. All right. Let me say the function x square, y equal x square. It will do that. True. I'm not going to put. I will enter now and see what you get. Wrong. Somebody tell me why it's wrong. Even I wanna have y equal x square, and this I know x square. Anybody has idea? You can tell me why it's wrong.
Could it be square matrix?
Yes, because you are squaring a vector here, it will not do it. So what you want to do is like, if you want to square thing, you have to square 1. You should say 1 square, and you will have after that 2 square, 3 square, and so on. All right. But when you do a square like that, it doesn't work. It doesn't work. So when you have operation on a vector, you got to do the following. I will write the same thing here. I will go back to the formula, and you have to fix it. You should add a dot before the operation when you are operating on a vector. Here you go. 1 square is equal. 1 square is equal 1, 2, 3, 4. So you have 1, 4, 9, 16. That's right. See? So when you want to do operation element by element, you got to put dot. Let me show you another one. It's important. Let's say x is equal 1, 2, 3. All right? That's x. And let's say that you want to multiply it by, let's say 3, 4, 5. That's why it will enter. If you write z equal x times y, what do you expect? Error. You know why? Because you learn in math, when you multiply, the number of columns of the first matrix should be equal to the number of rows. So x has 1 row, 3 column, all right? So x has 3 columns. So y has to have 3 rows. So if you want to multiply, you make the multiplication like, let me go here to the word here. If you want to multiply, let's say you have x is equal 1, 2, 3, and you have y equal, what we did here? 3, 4, 5. When you multiply, it's not right because the number of column, the way that if you want to multiply, the way you're going to do, you will say z. Of course, that's we call it z. The only way to do that, you will say the number of rows should be equal to the number of columns here. So one solution of that to make it that, because this is 1 by 3, and this is 1 by 3. So this one should be 1 by 3, and this is 3 by 1. So what about if I do x times y transpose? Like if I say x and then y transpose, like you flip the, is going to work or not? Let's say if this is like 1 row, 3 columns, when you make the transpose will be like 3 rows, 1 column. So the answer will be only one number. Let's say that if you say z is equal x time y transposed in Matlab like that, that's y transposed. You get one number. You get one number, 26, and that's true. You see, because if you do that, let me show you how you do it in using equation here. If you do that, let's say insert equation, you will have 1, 2, 3. That's a row vector, so that's 1. That's 3 elements. So we'll have 1, 2, 3. The other one will be vector 3 by 1. So we'll have something like that. That's it. So we have 3, 4, 5. So when you do that, oh, oops, I'm sorry. Then equal. So you multiply 1 times 3 is equal 3. Plus 2 times 4 is equal 8. Plus 3 times 5 is equal 15. Then you have 26. All right. If you meant that, you are going to use Matlab like this: z equal x times y transpose. But sometimes you don't want that. Sometimes you want to multiply element by element. What do you mean element by element? You want to multiply element by element. You want to multiply 1 times 3. You want to do that. 1 times 3 plus 2 times 4 plus 3 times 5. We said that this is another thing, that if you want to multiply element by element, why so it doesn't work, say x times y transposed. So what you do that, you say z equal X, it doesn't work like that. Element by element twice, dot before the operation. Oh, yes. So now I'll go. Let me try this. I'll say Z equal, remember, you got only one number here, 26. X dot star Y. That will, you see, you get three numbers, 3, 18, 5. So when you want to do that element by element multiplication, go ahead and do that. And we use that many times. So you understand that now. So now I know the mistake here that I should have dot before the operation on this one, because X is a dot here, dot here. All right. What about 6X? No, you don't need to, because you're multiplying constant. So you're multiplying 6 times X, 6 times 1 times 2 or whatever. Anyway, let's check. Run. All right. I like that when I get clear. Clean and clear, it means I'm fine. Here you go. Look at the curve that you got. If you submit this curve, that's wrong. Why? What is the cosine effect? Cosine is cosine kind of sinusoidal waveform. I know it's multiplying by exponential decay, so it should be like sinusoidal wave and decaying. That's not right. Okay. Do you know why it's not right? All right. I give you the chance. Tell me why this graph is not right. Even my code is right. Any idea? Huh? All right. I have something here in chat. No. If there is a syntax error, will be like I will have it here, but it's clear. No error. No error. Well, actually, because you forgot, I got from -2 to 4, so I'm missing a lot of data. Something like that, you need like 0.01 step. You need to increment by 1 of 100, you know, so you can calculate every single data, especially when it's changing dramatically like that. Now look at the, I didn't do anything, just I change the increment of the input. And of course, when you change the increment of the input, it will change the output, because Y depends on the multiplication and exponential function of each element in X. Let's just look at the result. That's the right, that's it. Do you see what difference can make if you are not using the right amount of increment? Well, sometimes we get, okay, I can read the number. What about if I just add something called grid? What will make grid when I write grid here? All right, let's see what happens. I have grid, so I can follow the curve and things like that. All right, that makes sense. Okay, well, so that's the way to sketch. I show you now to sketch a function, and the function has sinusoidal, exponential, and how you put it, and how that's really important. It will be a lot for solving many assignments, many problems. Okay, that's really great. Well, I want, let's do something, another equations. If you have like many function you want to sketch on the top with each other, so what should we do? Of course, you still can add here what I did. You want a red color, line width, whatever you want. But of course, in this one, I'm not going to put mark size, because I don't have discrete data. I'm having continuous data. It will be crowded. You can, but you can make the line width like. All right, here let's just write line width to make it clear for you to see at least line width. 2. I like 2. 2 is just a nice one. So I'll just go and see. You will see it clear now. Yeah, you see now you can see it clear. You can cut and paste and do it. You never cut and paste. If you want to sketch this one, you go, by the way, just edit, copy figure, and by the way, you have the copy option. Let's do the copy option. Copy option. It will tell you want transparent background, you want to force white background. I want to have white background. Which one? I will leave it metafile if possible. All right, that's the best one. Okay, So I agree, I apply. And then I will go and make copy figure. You don't make screenshot. And then I go to my Word file. And I'll just go ahead and just paste. Here you go. See? This is a force white background. All right. Now, if somebody asks, okay, what about if you don't want to go copy option, transparent, apply. Let's just see the difference. If we do that, copy figure, go to the file, paste. Oh, it didn't say anything. No, no different. All right. It doesn't make difference. That's fine. Should make difference, but that's the way it did to me. Do you have other option? Use figure color. That would be exactly the same. Some professor, they ask for that to make sure that you did it through Matlab. Copy figure. And go there, paste. You see, you got it exactly like in, but for me, I like that. I like that more. All right. Well, that's the figure we got. So let's go to the Matlab. All right. Now we add grid, and maybe somebody ask, can we add anything else? Of course, you can add a lot of things. Like what? Like, for example, that I want to have X label here. X label. So I'll go there and I'll say X label. Just write X label. That's nice about Matlab. X label, and then you want to like X label what? Let's say the X represent the time, for example. Say time in second. I want this to be print. And what about Y? Well, Y label. Y label. And let's call Y label function of X. Or function of time, I'm sorry. But this function of X, when I'm confusing you, let's call, for example, that we're calculating the amplitude, for example, the amplitude in voltage. All right. Let's now run, see if we did it in the right format. Can you see it? It's like a text, right? I mean, text. Run. No error. I'm happy. Here you go. You see? Time in second, amplitude. All right. All right. So can you add title? Yes, you can. How you add title? Just write title to be in the middle. Title, let's say voltage response, a step voltage response. Step voltage, that maybe you are making an experiment, step voltage response, you enter step input, and then you want to see. All right, so you got the title, no error, good. Here you go, step voltage response, time, amplitude, nice, nice, okay. Actually, you can do that without typing, but it will not be permanent. What do you mean? If you do it, this arrow, you can edit the figure in the way that you like. You just can add, you can do anything, you can hear, you can change, you can do anything, everything that you want. You see, I can erase now through the figure editing. I can write here without using that. But the problem, it will not be permanent. If I print it, it will not. Step voltage response. And there are many things, you know, how to make this one appear. There are many things, but just I show you, that's good enough. You have x-axis, y-axis, you have, that's not bad. All right. Okay, so let's go to another example. I promised you to do like, oh yes, different graphs on the same page. So let's go. I think I have the example here. Yeah, here you go. We have a function y is equal to 3x cubed minus 26x plus 10. And we want to plot this function, its first and second derivatives from -2 to 4. Good. In this case, you are going to, I'm not going to show you today how to find the derivative by using Matlab, but just to say this is the y, and then y is equal 3 x power 3 minus 26 x plus 10, and the derivative, call it yd, for example, the first derivative, it will be 3 times 3 is 9x, all right, 9x square, minus 26, and then 0. What's y second derivative? Ydd, okay, equal, you have 2 times 9 is equal 18 x. That's it. Well, just I'm doing that. I want to program that, and my x is from -2 to 4. I remember that. So I'll just go there, go to the Matlab. Just as I'll put in the here in the comment. No, I want to keep x's. All right, let's just do that. Oops, okay. So I have to put like comment on each one, just reminding me, and that's the enter. All right. Now I have x, the same thing. I'll keep it. Y, I'm going to change the y. And y here would be, I have it here in the top, 3x, 3 times, right? 3 times x square minus 26 times x plus 10. If I do any error, please just remind me not to continue. Well, the first thing, x is a vector, and I have multiplication and raised to the power. Actually, that's multiplication doesn't matter as a constant, but this vector operation a vector, so I have it dot here. That's constant, doesn't matter. All right, you see what I bought it when it's necessary. Yd, the first derivative, is equal to 9 times x power 2. So I have dot. Remember dot. Why? Because it's a vector. X is a vector, and I'm making operation over a vector. Minus 26. That's it. And then ydd y second derivative is equal to 18 times x. So that's the please just review. If I did any error, you can remind me. I was careful about the element operation. I put the dots before the thing. That's good. Now I want to plot. You see, y against x, yd against x, ydd against x. So how can I do that? Okay, forget about these things. Now. So, all right, forget about this. I just want to focus on something. Right? So the first will be between x and y. That's xy. Then what's second? Well, x and y, but I want to distinguish between the other graphs. So I will make it blue and only one dashed line. Oh, no. You can't do that. You have to make this one line blue. This is the first. The second will be yd. Yd against what? Against x. So you say x. You have to write x every time. X. Yd. You see what I'm saying? Every time you are going to sketch something, you have to mention it's x. This is x with y. What does it mean? The first 3 elements. I'm sketching y against x. I'm using blue color. I'm using one dash. And then I'm graphing yd against x, and I'm going to choose the format specifier here, 2 dash and red. I got the distinction between both, so I know which one. Then I will sketch ydd against x, and let me choose different color and specifier. So I'll just say 2 dots on top of each other, for example, and I choose this color. All right. So let's see. So you understand? xy with its own specifier, xyd with its own specifier, to distinguish between them, ydd with its own color and own line specifier. Now I'm going to run. Hopefully no error. Good. Now let's just click what's up. Here you go. And when you look at the graph, All right. The blue one, I know it's for y. This is the y function. And the red one with broken dashed line here, the red one, it's the first derivative, this one. And the third one, which I make it two dots on top of each other, that's the second derivative. So I created three graphs on the same page. All right, three graphs on the same page. So sometimes you like to see each one separate. If you guys have questions, just you got to speak to me and tell me, right? Let's now, you see the three graphs on top of each other. Is there anything else we can play around here? Yes, we can. When you do the plot, you don't want to do it like that. Let me just print it like 3 times and I'll show you about some trick. And this 1, 2, 3. I'll do the first XY blue and then I will delete this. I don't have to write them on the whole line. All right. And then I will type hold on. So it will hold on, and every time I hit return, it will show me the other one. Then I wanna the second one, XYD with the specifier, and then I will cancel all this. All right, and then I hit enter. No, I don't have even to have hold on every time. Hold on will understand that whatever is coming by hitting enter. So the third one between X. Oh, what is that? I want to cancel this. And I have X with YD. Okay. Then when you are done, so when you start hold on the first one, it means the first graph is created. And then you have 2 more graphs are added to the figure. And then when you are done, you should, your handle hold on, it changes into hold off. And you're done. So again, I don't have to write all of them in one statement of plot. I write the first figure and then I have hold on, and whatever I have, 2, 3, 4 figures, I write it in, and then when I finish, I said hold off. All right. Let's just run, see if I did any error. No error. All right. See, run. And you have it here. So that's one. Another one. How can you do that without typing all of them on one line? Well, sometimes in some application, we got to do that in separate screen. What do you mean separate screen? You see this screen, I'm talking about the figure screen. Let me just clear the figure. So CLF. Now I'll go back. Here is empty. All right. Oh, this is annoying me here. Okay. That's the screen where you plot the graph. This screen, you can divide it, whatever. For example, you have here 3. Maybe I want to divide this into 3 figures in the top of each other. So we are dealing with this screen as a matrix. So if you want to divide it into 3 graphs into other, it means you have 3 rows, 1 column. So what you'll do the following. You write here subplot, and they say you have 3 rows, 1 column. And let me use the Word document to tell you what do I mean by this. So it means that if you have screen divided into this one, this is screen 1. Okay. And this is annoying me. Okay. What function does 0.1 do in between 2 and 4? Is it the max? No. 0.01 is the increment. I have a question about point. Let me answer the question first. When you say from -2 0.124, it means that the first point is -2. All right. Let me make it an easy example. From 2 to 4. So you'll not be distracted by the negative sign. From 2 to 4. If you don't put 0.01, it will be 2, 3, 4, and that's it. But if you have 2 and 0.01, it means the first one is 2. The second element will be 2.01. The third one will be 2.02, 2.03, and so on. You are adding 0.1 every time. Got it? All right. Now Now let's go to right. I'll just make it in the middle to make it nice. If you divide your screen like that, so you will say that you have 3 rows, 1 column, and this is the first screen. The second one, we have 3 rows, 1 column, and this is your second screen. You have 3 rows, 1 column, and this is your third screen. All right? That's the way you divide it. You can't divide it more than that. For example, sometimes I need to have 4 graphs, but it's very crowded to make it on top of each other. I make it like that. So how you write? But by the way, then you add here subplot. And the same thing here. Boom. Copy, paste, copy, paste. All right. Let me show you just practically how I do that. Let me just, I'm lazy to, all right. Okay, don't be lazy. Don't be lazy, Gatti. Okay. So you will say subplot 3111. And this is your first one, but how you write your first one? When you make subplot 311, and next to it, you can write your first one. You want to do the plot. Forget about hold on now, because I want to do it in separate screens. And then here you get subplot. Just copy this one. But before I do that, let me make a comma here, separate them. Subplot, copy here. But now this is your second screen. The division the same. The first 2 digits, the division. The third one is the location. So that will be the third screen. All right. And let's just put comma here just to make sure they're separate. Now, you don't need hold on, hold off, because you have. Look now at your screen, what happened. Hopefully that I didn't do any error. All right. Here you go. You have 3 screens. Oh, you want to have grids everywhere? All right. Just add grid after each one. That's not bad. Grid. And you can add whatever, the axis, the anything, title. But sometimes you need 3 separate screens, like oscilloscope here. See, that's your first one. You can write the title Y against X, YD against X, YDD against X. So what I did, I said 3 rows, 1 column. So that's 3, and that's 1. And this now 1 first screen. This is second screen, the third screen. I told you that you can divide it into 4 like that. So what? How many rows? 1, 2. So you got 2 rows, you got 2 columns, and this is your first screen. You got 2 rows, you got 2 columns, second screen, and so on. Let me just go ahead because we have just 7 minutes. So I will go there and let me do it 2. Of course, I will have 1 empty. I don't need 4, but just I'm just trying to show you. You have 2 rows, 2 columns, 2 rows, 2 columns. And this is second. And 2 rows, 2 columns, and this is the third. All right. 2 by 2 give me 4 screens. So I have 1 empty, I expect. So let's just run it. No error. Oh, I'm lucky today. Yes. Here you go. You have 4 screens. That's your first. This is your second. This is your third. Your fourth. Nothing. You don't have 4th graph. So that's the way how you do it. I'm done, guys, with the portion of plot I want to do. Of course, we have many things fancy you can do. You can do 3-dimension plotting thing, but this is the basic because you need to learn how to plot the function if you do any simulation for circuit, electronics, or mechanical engineering. You need to get the response. So you got to plot your answer. All right. So this is the way you do that, and this is the way you control it. Any question? Do you have any question? All right. Okay. See you next Tuesday.
Thank you.
You're very welcome.
Have a nice day.
You too. Thank you.
Take care,
Have a
Dr.
good day.
Gelson.
Thank you. Thank you. I enjoyed.